Hi guys. So we're now trying to tackle like the longest increasing subsequence. This is a dynamic programming problem. The way to tackle dynamic programming problems is basically uh, I think a lot of people skip like the intuitive way and they just jump right into the bottom up. But that's like really not intuitive. It's like it doesn't explain like how you arrived at the bottom up solution. So there are two. So what usually I think makes a lot of sense is like you draw the decision tree, and then you go top down because you memoize after finding similarities. So that's like the intuition. So once you develop that, then you go bottom up. So bottom up here like means like basically like build solutions from the smallest subproblem. I think this is very unintuitive because like yes, you should explain this in an interview like how you uh, like have the bottom up solution, but I think it's also really important to like focus on the top down solution because even though it's a little bit slower, it's like a little bit it is easier to understand. So given this example, right? So the problem is like if we have like a sequence, a number of strings, like how can we form the longest possible subsequence? Subsequence being like you can it's just like part of a sequence. So here like 2 and 3 would be 1 and 4, 1 2 3. You basically like it's like cutting up like a set of strings and like attaching together. I think that's like the analogy. You have like a long string here and then you cut this off and then you attach that part. So that's like the analogy that I like. And so what you're doing now is you want to find the longest possible length, increasing, right? So basically like x1, x2, x3, dot, dot, dot to xn, right? Where all of them are like strictly increasing. So that's like the idea you want to have. And the way to do it is like just try to draw like a decision tree. So like just spell out what you can possibly do. So starting at the node, the blue things represent like the index. So here 0, like you would have 1, right? And 1 would be 2, and then 2 would be 4, and 3 would be 3, right? Does everyone see that? Like this is 1, 2, 3, 4, 3, right? So like basically like every point you can start out with 1, 2, 4, 3, right? And then here 1, like you have the choice of like adding 2, 4, or 3. Does that make sense? You have 2, 4, or 3, right? Index 1, 2, and 3, right? So it becomes 1, 2, 1, 4, 1, 3. Does that make sense? So now you're at 1, 2, right? So 1, 2. If you pick the second index, you become 1, 2, 4. If you pick the third one, you become 1, 2, 3. Try to like pause it and like think about it. But yeah, that's like the idea. And here, I think I did that. Yeah, so if you originally start with the first index here, you would have 2, and then you would have the second index, right? So you would add 4, and then here, 2, you would add the third index, right? So it would be 2, 3. So pause the video and like try to like work it out yourself or like draw it out. I think that's really helpful. Yeah, and 4 obviously you can't go any further because like 4 and 3, can you clearly see like 3, the number 3 is smaller than 4, so we can't add the third, so that's why it stops. 3 also is the last index, so it stops. So here 2, 3 stops, 2, 4 also stop. So the idea is like we can like find similarities. I will define like LISK as the length of the longest increasing subsequence starting at index I. What does that mean? So here you start at like index. So you should start from the back actually. So you start at index 3, right? So here the longest increasing subsequence at index 3 would be 1. Does that make sense? Because here you can't go any further. So that's why this is 1. So now, since we populated the decision tree, so let's say we start at like 4, the index 2, right? And then we want to find the longest increasing subsequence, 4 and 3, right? 3 is smaller than 4, so the longest subsequence that we have is just 4 itself. So that's why LIS of 2 is 1. So now, So here, LIS of 1, here it's index 1 would be the number 2. So if you see here, right, so this is the decision tree. This is a branch that we want to look at. So starting at 1, right, so we would go to this one, and then, yeah, we can add index 2 and index 3, right? So it becomes 2, 4, and then 2, 3. So now, if we start at index 1, the longest possible length we can have is 2, right? That's the only thing we can have. So here, that's why this becomes 2. So now, this is a big bad boss here. So you start it with this branch, you add 1, right? And then you populate the tree accordingly, right? Like this is how you get. But these values, so these values are of length 2 and 2, right? And these are of 3 and 3. So that's why the longest possible subsequence starting at index 0 would be 3. So like I'm not sure if you noticed, but like I populated the tree like from the backwards, and this is where like the bottom up comes in. So here bottom up means building the solution from the solve subproblem. So like the longest increasing subsequence starting at index 3, that is 1, right? Because there's only the number 3. So now we want to do LIS of 2. So we basically have like 2 contenders. The length of 1, where like it starts, or you basically have a subproblem here, right? So you have like you have LIS of 3 plus 1, so that could be another contender. So these two, 1 and 1 plus LIS plus 3 is like a contender. But if you notice, like nums of 2 and nums of 3, this does not hold. See here, 0, 1, 2, 3, right? So this one is bigger than that. So this one is not valid. So LIS of 2, the value is like the max of these, or max of 1 itself, so it's just 1. Similarly, LIS of 1 is just 1 itself, and 1 plus, like the subproblems here, right? LIS of 2 and LIS of 3, basically. So that's why, do you see how like you're slowly building up? And that's how like the bottom up works, actually. Yeah, so here you give 1 plus LIS of 2, which is 2 here, and then 1 plus LIS of 3 is also 3. So the max of this would be 2. Let me just double check if I am doing this correctly. Yeah, so that is correct. And here LIS of 0, so there are 4 contenders. So 1 itself, and then 1 plus LIS of 1, right? And then 1 plus LIS of 2, and then 1 plus LIS of 3. So here this would be 2, right? LIS of 2 would be 2, and this would be LIS of 1 plus 1, that is 2. No, sorry, 3. So LIS of 0, so the answer that we have is 3. So the idea is like you build up solutions from the smallest problem. This is O of n squared. There's a binary solution that exists. I didn't really explore that. If you guys want, I can do it. Please let me know. I won't share the code. Please try to code this up. This is like, the bottom up is like the way how you build it. I think like how, yeah, I think this is like an idea of how to build it, do the bottom up solution. So basically the intuition is like you start from the back, slowly do what you can, and then you find the longest possible subsequence for the last one, and then for this one, and then for this one, and then this one. So like it slowly adds information. Yeah. So you have to like build sub problems. So certain dynamic programmings actually they start from zero index and then you populate that. You can design it that way, but I'm not sure if that makes intuitive sense for this problem. But here, like the key intuitive skill is like trying to build it, trying to break it down the smallest possible sub problems, and then use those sub problems to build like the next one, and then you use that information to like build another one, and then finally you arrive at the answer, right? So you at index 0, all of this information will be squeezed in. So that would generally have all the information. So that's the intuition. So I just want to wrap up by saying that the transferable skills here that you can use, the longest increasing subsequence. Obviously, like we can't solve every problem. I think it's like really important to solve like the classic problems and like have a deep understanding of them and use those skill sets to solve different problems. And I think like companies, they know like people are so good at leak code, so what they do is like they create like custom questions. So like chances are like you could go into an interview setting and like really see a question like you've never seen before, and actually no one outside the company has seen before. So you should have like a really strong understanding by grounding the fundamentals. So here, like DP, like there's both top down and bottom up, like try to draw a decision tree, find repeated patterns, and then memoize. So this would be like the top down part, and then the bottom up, yeah. I think it's really hard to jump right into the bottom up unless you're like a genius or something. And then here, like the sub problem formulation and state tracking is like really important. The number of islands, graph traversal, DFS, or BFS. There's a way to solve BFS. I think Yone solved it in BFS. Yeah, if you can reach out to him, I think maybe he'd be happy to like talk about it. I'm not too familiar with like the DFS solution for this problem. Yeah, for those of you who don't know, DFS is basically like you traverse, the way you traverse, like you travel like level by level in a tree, basically. That's how it works. I think you use a stack or something. And then here, like you basically, this is kind of important. You should try to like check the boundary checks for the grid. I think, yeah, and that's it. Thank you.